Okay, let's do a very simple machine learning with Ascend. So let me fire up a Windows subsystem for Linux, and then go to the Ascend directory, and then activate the Ascend environment. And then we're going to launch the graphic user interface with the Python command. And then we go to the local host, 47777. So we're going to load up the CSV file, spreadsheet-like type of data set. And the data set that I'm going to use today for demo is the housing price of the Boston area, which I downloaded from the Kaggle. So this is the structure of the data set. So it has lots of the input features that affects these the target value, which is median value. So the input features are consist of like a number of the rooms, age of the house, text, and so on. And then we have a number of the data set, and we have a lot of data set like this. So let's try to include all the features into the input column and then target column. So we're gonna first move all these items using this add to input column button. And as you can see, they all are loaded up. But we don't want to use target value as an input. So we're going to remove this by clicking this remove from the list button. And then we select this and then add as the target column. Now it is ready to be analyzed. So one of the key features of Ascend is providing the correlation analysis. So it is good to know what are the impact of individual features on the target property. So by clicking the perform button, we can get the score of the individual features that affects this target. So LSTAT is the strongest factor, and then room and text, we can see which one is stronger and then which one is less important, and so on. This MIC is a maximum information coefficient, quite advanced algorithm that can give us the correlation between input and then output target based on the linear and also nonlinear relationship. And also we have the conventional Pearson correlation coefficient, so that we can have the negative, positive and negative correlation. So of course, the more the room you have, the higher the value. And the other way, like for example, the higher the crime rate, then the lower the value. So it kind of gives us the value that agree with our common sense, and it gives us the more quantitative score, so that, for example, the text has more influence than crime, things like that. So we can have a pretty good idea to validate our existing hypothesis, or based on the new feature that you inserted, we can generate a new hypothesis, again, based on this kind of quantified score. So with that, we can proceed to the machine learning by clicking this button, or we can click this tab to go to the next stage. Now that all the features are loaded up, we can do the machine learning. And then all the most of the popular machine learning algorithms are pre-embedded, and we can use the different scalar, and then we can use the k-fold method, so that when the number is 5, then all the data set going to be divided into 5 different beans, and then 4 of them will be used for training, and then 1 will be used for testing. So you can change this number as you wish. So we'll just click the perform test and then see what we get, right? So now we quickly got this parity plot that compares the predicted value and then actual value. So this is actual values are numbers that in the CSV file, and then this is the predicted value of the median value with all this given input features. And then this is the score that we get. So R square 1 is perfect match, and then this is the error shows the goodness of fit. So let's just click it a couple of times. And as you can see, the R-square changes slightly, but not a lot. That means that we shuffle the training data set and then validation data set. So that depends on that shuffling, the R-square value changes slightly, right? So that's what we get. And as you can see, it didn't change much. So there is not much of a noise in this data set, okay? So the whole purpose of the training machine learning model is making a trend prediction. So let's just try to save this model, and then let's try to make some prediction. So let's save the model, and as you can see, what we have just saved is shown in here, and then we're going to go to the next stage to make a prediction. So this is a pre-trained machine learning model, which can be used for prediction. So as you can see, we can have all the features shown in here, and then this is the R-square value. So I'm going to load up the input file, which is again the similar structure as the training data set, but it does not have the median value because it has all the same dimension of the input features, but it does not have MDEV, median value, which to be predicted. So we're going to select all, and then we're going to make a predict selected. And then just like that, we can make a quick prediction of a median value based on all these input parameters, right? And then we can export to different values, different format. So we can just make we can have a quick look. So it's pretty much the same. So we say this is the model that was used. And then this is a predicted median value based on the training that we have with all these input features. So this is how you train machine learning model from a given spreadsheet like data set, and then train the machine, do the correlation analysis, and then train, and then make a prediction with a sense. Okay. So if you have any questions or feedback, leave the comments in this video, and thanks for watching.